Today we're going to be talking about like terms and the distributive property. This is my favorite, most favorite property to talk about. What are like terms? Well, what does the word like mean? That means things that are in common. What do things have in common? So when we're talking about like terms, we're talking about numbers. For example, 7 and 3. Yes, those are like terms. Why are they like terms? Because they're both numbers. Number 2, x and 3x. Are these like terms? Do they have anything in common? What do they have in common? They both have an x, so yes, those are like terms. Number 3, 7y and 2y. Are these like terms? Well, they both have y's, so yes, those are like terms as well. Anything that has something in common. They both have the same variable, so they're like terms. It doesn't matter what the number in front of the variable is. If you'll remember, when we have 4a, the variable is a and 4 would be the coefficient. So the number in front of a variable is called a coefficient. Here the coefficient is 7, here it's 2. Again, it doesn't matter if the coefficients are different because the variable is the same. Example 4, 3m and 7n. These are not like terms. They are not like terms. Why are they not like terms? Because they have different variables. This is 3m, this is 7n. Different variables, not like terms. Number 5, 4p and 4n. Are they like terms? They're actually not like terms. The variables are different. It doesn't matter that they have the same coefficient because the variables are different. Combine like terms. To combine, we're going to add things together or put things together. It's not always adding, it could be subtraction. We're going to combine some like terms. Example number 1, 7m plus 4 plus 3m plus 9. First thing I do is look through and see, do I have any like terms? Let's circle those. 4 and a plus 9. Why are those like terms? They're both numbers. What is 4 plus 9? 4 plus 9 gives you 13. Why is it positive? Because a positive 4 and a positive 9 is a positive 13. Then the other like terms that we have are 7m and 3m. The thing that they have in common is the m. So we have 7m plus 3 more m. So if you have 7m and you add 3 more to that, 7 plus 3 gives you 10m. So 7 plus 3 is 10m. We have 10m plus 13. That is our answer, believe it or not. You cannot combine 10m and 13 because here we have a variable, here we just have a constant, a number. Number 2, 4m plus 7 minus 3m minus 5. Let's look for those like terms. First, let's do the variables this time. It doesn't matter what you do first. 4m and a minus 3m. You always look at the sign in front of it, So 4m minus 3m. So if you have 4 and you take 3 away, you have 1 left, 1m left. Now let's look at our numbers. We have positive 7 minus 5. Let's combine those. If you have 7 minus 5, you're left with a positive 2. Your answer would be 1m plus 2. You can actually write that in a simpler way. If we just have 1m, you have m plus 2. No need to write the 1m because you know if it's just an m, it is 1. Example 3, 4x plus 9y minus 1. Let's see what we can combine. Do we have any other x's? Nope, no other x's. Do we have any other y's? Nope, no other y's. Do we have any other constants or numbers? Nope. There is nothing in this expression that we can combine. So this is already in simplest form. That would be our answer. We will now move on to the distributive property. We learned about associative, commutative, identity properties a few weeks ago, but today we're going to focus on distributive. It is my personal favorite property. I just love it. Okay, the distributive property, I always use arrows to help me. It tells us that when you have two numbers that you're adding together, you can either add them together first and then multiply a, or you can multiply each part by a and then add it together. Now that seems a bit confusing. A times the quantity B minus C is A times B minus A times C. A little confusing, so let's look at a few examples to clarify. We're going to simplify these expressions. Notice here we have number 1, 4 times x plus 3. We have parentheses. Anytime you have a number or a variable outside of the parentheses, the operation that's implied is multiplication. The distributive property tells us to distribute that 4 to all parts of the inside of the parentheses. We're going to distribute. Now, when you think about distributing, you have to think about being fair. If I was going to distribute candy to the class, would it just be fair if I distribute it to 1 or 2 people? No, I need to distribute it to everybody. So we need to be fair and make sure that 4 is distributed all the way out. Let's do it. 4 times x. 4 times x is 4x. You then have to come back up and do 4 times 3. 4 times 3 is 12. Bring down your addition sign. If there's an addition here, it's going to stay addition. We have 4x plus 12. That is our final answer. We can't combine any like terms here because we don't have any more x's or any more numbers that we can add together. Your final answer is 4x plus 12. Number 2, let's use the distributive property. How do we know to use the distributive property? We have a number or a variable outside of the parentheses. That tells us to multiply that number inside. This example, that 4 is behind the parentheses. I always like the 4 in front. You can do it from the back, but I like it in the front. So I'm going to move that 4 to the front. 4 times the quantity m plus 11. Let's use those arrows. 4 times m, that is 4m. Second thing, 4 times 11. 4 times 11 is 44. Again, bring down your addition symbol. 4m plus 44. That is in simplest form. You cannot combine those terms because this has an m and this doesn't, so you can't combine. Number 3, distributive property. 6 times the quantity x minus y. We're going to take that 6 and distribute it inside the parentheses. 6 times x. What is 6 times x? It's 6x. Bring down your minus sign. Gotta remember to be fair. Do 6 times y. 6 times y is 6y. You're left with 6x minus 6y. We cannot combine these. Even though the coefficients are both 6, the variables are different. You cannot combine unless they're the same variable. How is this the distributive property? Let's recap. The distributive property tells you you have a number on the outside of the parentheses and you can multiply it into each part. We did that with the 4, and the 6. We have a couple of examples left where we're going to combine like terms and use the distributive property. So we're going to be doing it all in the same problem. Number 1, again, we're going to simplify. Number 1, 4 plus 2 times x plus 5. Here, you see that you have parentheses. Look in front of that parentheses. We have a 2. That means you're going to be distributing 2 to that parentheses. Order of operations tells us that we do parentheses first. So we do not add 4 plus 2 because we haven't distributed the 2. Let's go ahead and get started. 2 times x is 2x. 2 times a positive 5 is a positive 10. We're left with 2x plus 10. Bring down your 4 plus. Once we get to this step, you have to look and see, do I have any like terms? Well, yep, I sure do. I have a 4 and a plus 10. What is 4 plus 10? That gives us 14. I also have a 2x. 2x plus 14. You can't combine it any further because they are not like terms. Number 2, 4 times the quantity x plus y plus 3x minus 2y. Again, we have the distributive property. We're going to distribute that 4. 4 times x is 4x. 4 times y is 4y. Bring down your addition sign. You also bring down the 3x and the minus 2y. Why do we not distribute the 4 to those? Because they are not inside the parentheses. All right, here we have to look and see, do we have any like terms? I sure do. I have a 4x and I have a positive 3x. What is 4x plus 3x. Remember, that is a 7x. Then I have a 4y minus 2y. 4 minus 2 is 2. You're left with a 2y. Our final answer is 7x plus 2y. Can't combine those, they're not like. Example number 3. Here I'm going to be using the distributive property 2 times. Let's start out with the first step, because order of operations tells us to go from left to right. 2 times x is 2x. 2 times 8 is 16. You're left with 2x plus 16. Let's do our second part, which is the second application of the distributive property. 2 times x is 2x. 2 times 5 is 10. Again, bring down your addition. We brought in our addition. Here we're left with a nice, long, non-simplified algebraic expression, but you know how to simplify. Look for like terms. We have a 2x and a 2x. What is 2x plus 2x? Well, 2 plus 2 gives us a 4x. Now we're left with 16 and a plus 10. So what is positive 16 plus 10 more? That's going to give us a plus 26 or a positive 26. Our final answer is 4x plus 26. Why can we not combine those? Because they're not like terms. Last example. 9 times the quantity x plus y minus 5y minus 3x. Here we're going to be using the distributive property. You only distribute the 9 to the x and y. Why don't we distribute it to the 5y and 3x? Because those are not in parentheses. 9 times x. 9 times x is 9x. 9 times y. 9 times y is 9y. Make sure you put your addition symbol in between those. Next, bring down your 5y and your minus 3x. We're going to look to see if we have any like terms. We sure do. 9x minus 3x. So you have 9 and you take 3 away. You're left with a 6x. Let's look for our other like terms. 9y minus 5y. Remember, use the sign in front of the 5. 9y minus 5y. Well, 9 minus 5 is a positive 4y. You're left with 6x plus 4y. Again, we cannot add those because they are not like terms.